Jim, and I'm hanging out on the side here by this box you wanted me to look over.
See all the Great Lakes, see Detroit, see Windsor, Toledo, see the St. Lawrence River.
Okay, Hank, for the EPM drive room, there's a pretty bright spot over on the very west limb here. It's probably active reaches 7 or 3. And we're taking a look just over the eye of the hurricane at 43 plus 15, just a little bit earlier than your prediction. And should have to...
It's very, very easy to fly. It flies just like the simulator, and maybe a little bit easier.
In the months of August and September 1973, a second crew of astronauts lived and worked aboard the Skylab space station. During that 2-month span, these men generated a staggering amount of scientific data. Data that in some cases will take several years to analyze, and whose impact the scientific world has yet to fully comprehend. For the record, it was the second manned mission of Skylab. But owing to overwhelming success, it might well be called a scientific harvest. July 28, 1973. Skylab, with well over 1,000 Earth revolutions, begins its 75th day in orbit. Except for ground solar observations, its systems have been mostly silent for more than a month, having been powered down when its first tenants departed. Today, the slumbering space station will again be brought to life when the second crew arrives for an extended stay. Their journey will begin at Kennedy Space Center, Launch Complex 39, embarkation point for most of space history. Transportation for the flight is the 2-stage Saturn 1B, which is well along in the pre-dawn countdown.
Who's calling? Hydraulic pressure coming up on fin 2. All right, stand by.
In nearby launch control, the vigil is centered in firing room 3. Here, the staccato of digital readouts tells the launch team that all systems are go. The countdown is smooth, almost routine. For the crew, the lectures, the briefings, the simulations, almost 2 years of intensive training is behind them. Today, they begin the real thing. Navy Captain Alan Bean, senior member of the crew, is Skylab commander. In November 1969, as lunar module pilot of Apollo 12, he walked on the moon. The science astronaut and civilian member is Owen Garriott. He brings to this mission a well-rounded background in science and engineering. The pilot, Marine Corps Major Jack Lausma, who served on support crews for 3 Apollo missions. For the 3 of them, the longest space flight ever is about to unfold.
Get liftoff. We'll be looking for liftoff right at the T0 mark. We passed the 15-second mark in the count. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition sequence start. All ignitions are running. All engines running. We have a liftoff. Second man crew has cleared the tower.
By all accounts, there had never been a smoother launch sequence. Rendezvous occurred just off the U.S. Pacific coast, almost 8 hours following liftoff.
Sky, Dick. Well, the old parasol, Dick, is really blowing in the breeze. Looks like about a 10 or 15 knot gale every time the thrusters fire, and just a very gentle fly around here.
Roger, we were watching that very thing there.
Al thinks he'll probably knock off the fly around at this point to avoid blowing that thirst all the way.
Skylab Houston, we've taken a look at both the CSM and the Swiss. They both look good. So go for docking. We're about a minute and a half from LOS.
Roger.
Okay, we're docked. That went real well.
An oxidizer leak in one of the quad thrusters was the only blemish on an otherwise perfect flight. The leak would mean a slight loss in attitude control on the return flight, but at this point, it appeared to be well within backup control capabilities. Leaving the detailed analysis to ground specialists, the crew wasted no time moving into their temporary home. Within an hour, they had begun restoring Skylab to a living, working environment. Activation consumed the better part of the first week because not everything went according to plan.
I closed the circuit breaker on that beauty, and it popped open. And so then I turned the switch off and closed the circuit breaker, then turned the switch back on, and the circuit breaker popped open again. So something's wrong with MOSIP B secondary fan.
To give you a feel where we are at the moment, we're beginning to eat our meal right now. We've had to move extremely slowly to keep from causing any vestibular problems with ourselves. By that, I think both Owen and I have a little bit of stomach awareness, so we tend to be fairly careful how we move. And since we are moving rather slowly, then it's taken a little bit longer than we planned.
Because of built-in mission flexibility, the delay had little impact on overall scientific gain. The flight plan was adjusted as required while the crew continued to make headway. The solar astronomy instruments were, meanwhile, delivering data in the unmanned mode. Medical experiments got underway. And some of the corollary science and student experiments were initiated. For example, these Minchmog minnows, being set up for observation, appeared to lose orientation in 0G.
They would usually float with their belly towards the wall, and then after doing that for a while, then they'd swim in outside loops again. So apparently they can't make up their mind which way is up and down either.
Yes, sir. Good observation.
Another passenger from Earth was Arabella the spider. This was a student experiment designed to find out the structure of the web she would spin in the weightless state. On mission day 6, a second quad thruster indicated failure. Even so, command module control was still adequate for the return flight. However, the uncertainty of additional failure prompted an urgent decision.
Hey, Al, this is Chris Kraft.
Go ahead, Chris.
As far as the RCS system is concerned, we really can't determine at this particular moment whether we have a generic problem or whether we have some two unique problems with these quads.
Now, just to be prudent, however, we have started the preparation of the vehicle at the Cape on a accelerated basis so that we would have a rescue vehicle available to us should that become necessary. Okay, now, I guess in concluding, I'd like to say that further that we're proceeding here with
as if we're going to have a nominal mission. And if you feel like you need any further discussion on this thing,
feel free to call us in any way which you want to.
John, you just said the right words. We've been hoping you'd say that all day, ever since we found out that that was a true problem that we had with our quad this morning. And we agree 100% with what you just announced.
Okay, so be it.
So as a precaution, rescue plans were set in motion. Whether they would be carried out completely depended on assessment of the thruster problem, a problem that could now be fully explored. As the mission entered the second week, the crew stepped up the medical protocol, somewhat slighted up to now because of more pressing needs.
We also have a way to measure our heart rate. And this reads out our heart rate, beats per minute, as we're pedaling. Of course, the harder you pedal, why the harder your heart has to work, and the better it is for your cardiovascular heart system. While we're pedaling this bicycle during the medical experiment, our breath is analyzed in this metabolic analyzer so that our pulmonary system can be thoroughly evaluated during the period that we're up here. This is used in combination primarily with the lower body negative pressure experiment. The man slides in from the top here. He slides into his waist. Then we pump him down to semi-vacuum. That draws his blood from his head down into his legs. It's a good measure of how well his cardiovascular system is performing over long term in space flight. Of course, that's one of the reasons we're here. The purpose of the rotating chair is to determine the response of the vestibular system to zero gravity. And we've been doing many experiments on this to see how the balance mechanism in the inner ear is affected by weightlessness.
Food log. CDR, 4 salt packs and 1 strawberry drink.
Other medical data was compiled from an accurate reporting of the daily food and fluid intake. Body waste and food residue were weighed daily. And the wastes were either dried or frozen for return to Earth for analysis. The weight of each crewman was also checked daily, not by conventional scales, but by a device that electronically counts time of oscillations of the subject to determine mass. And blood samples were taken. The samples were frozen and later returned for post-flight analysis.
Okay, you're up to start, Jack. Tape motion is working. Let her fly, Al. Stand by for an auto cal at 3 seconds. Go. 1.
The Earth Resources package was enabled. Its 6 remote sensing systems put into full operation.
Well, I guess we're crossing the northern border of the U.S. right about now. Over Montana. The border over Montana, coming down through North Dakota and then Minnesota. One of our major objectives in Skylab is to look at Earth and its resources. We want to look at its forestry and its agriculture, its freshwater resources, its weather, its pollution, and a number of other resources that are very important to us on the Earth. This is called our Earth Resources Experiment Package. It consists of about 6 experiments with which we look at the Earth, and we spend a lot of time taking data here. This particular instrument is a telescope, and we can see resolution down to 1/4 mile square. For example, we can see a city block with this telescope. Let's take a shot off the coast of Chicago there. Okay, there's a little bit of tracking in Lake Michigan just east of Chicago. We have another battery of experiments also that are associated with Earth resources, and they are these cameras that take actual photographs in different wavelengths of light. And then these photographs then are returned to ground and processed and evaluated. And the purpose, of course, is to learn how to use our resources on Earth more efficiently and more effectively.
Handheld cameras were also unstowed, their lenses aimed at Earth through the wardroom window.
Okay, and we got that storm story. It's got a nice spiral effect. and it just doesn't look very strong yet.
This is Skylab Control at 11 hours 55 minutes Greenwich Mean Time on mission day 10. Today's entire crew schedule is devoted to the extravehicular activity.
This was the first of 3 scheduled EVAs. The amount of work to be performed would make it the longest.
I don't know, I've got to check now. Do I have any twist above me, Jack? Nope. Okay, now let me see about this.
Erecting a new sunshade over the workshop was their most difficult task. The parasol, deployed from inside by the first crew, had done an adequate job of thermal protection, but temperatures were still high in places, and too, the life of the parasol was questionable. The sunshade would even out workshop temperatures, and it would endure well beyond the final mission.
Everything's going in good up here. They're working at a slow, steady pace, and nobody's tired. So I have a feeling that the last half is going to go a little bit faster. We were the most concerned about this one because we didn't want to lose any parts.
Okay.
The EVA consumed about double the time allotted, but all tasks were successfully performed. The total time outside the workshop was 6.5 hours, a new record for orbital EVA. Temperatures began to fall before the day ended. They eventually stabilized at around 75 degrees, providing the best environment in the workshop since it was launched.
The ground will enable you to see
The following day, the Apollo telescope mount was put into manned operation, allowing quick and accurate pointing of the telescope array at current solar phenomena.
Now, to begin with, when I switched to the 2 positions called H-alpha, these words stand for hydrogen alpha, and they are called hydrogen because the light that we see comes from light radiated by hydrogen atoms in the sun's atmosphere. Now, this light is in the visible wavelength range, and you can actually see these things, these pictures on the ground as well. They're about the only instruments that we have of that nature. And we use them here because we see much of the fine detail on the sun at these wavelengths radiated by the hydrogen atoms. For example, we can see sunspots, we can see network, we can see filaments, all of these things on the sun in great detail. Now, the next display that I'd like to discuss briefly is a white light coronagraph. Now, this coronagraph also records or images pictures in the visible part of the wavelength. But it has a very unique feature which makes it something that cannot be observed very often from the ground. And this is, it has some occulting discs out in front of the telescope, so that the center of the image, the disk of the sun, is blotted out, and all we see is the very faint light coming in from the solar corona. Now, those of us on the ground can only see this at those very infrequent intervals when we have a total eclipse of the sun. Now up here, we're essentially looking at a total solar eclipse all day long. And we monitor the changes that occur in the corona, and once we tie all of our pre-missions together here in Skylab, we will have monitored the changes that occur in the solar corona over a period of over 5 months. And some of the changes are dramatic indeed. We have, as a matter of fact, recorded some very large transients that occurred in the solar corona. A large bubble of gas was blown outward through the solar corona. It stretched the magnetic field lines out like rubber bands, and finally burst the rubber bands, and the gas continued far on out into the corona and eventually reached the environment of the Earth. Now, when these gas bubbles do reach the environment of the Earth, they cause some very interesting things which we can see, or you can see, on the ground. Aurora are one of the most fascinating things that are produced by the arrival of these clouds of gas and magnetic field disturbances. And when they arrive and perturb the Earth's magnetic field, in some way not fully understood, the auroras are produced.
Dr. Garriott went on to explain instruments that record in the extreme ultraviolet and instruments that provide data in the X-ray wavelengths. And he talked about that interesting phenomena we call solar flares.
Flares flyers, for example, are some of the most outstanding transients. We've had the good fortune to see several of these since we've been up here in the last 4 weeks. And when these events occur, we very quickly go over and train all of our instruments on those flares and begin taking photographs as rapidly as possible in as many wavelengths as is possible. And we hope to better understand what produces these flares, what is the size of the flare, and perhaps better understand the mechanism by which these things are produced.
Skylab telescopes also reached out beyond our sun to record the ultraviolet spectra of distant star fields. Early type stars, too faint to be seen with the naked eye, were photographed, as were the abundance of young, hot stars in the Milky Way. In conjunction with this experiment were 2 student investigations designed to obtain ultraviolet spectral data from known pulsars and quasars. In related stellar studies, other instruments were activated to provide a panoramic view and measure ultraviolet brightness of a large number of stars.
The observers down here trying to get squared away to get some pictures.
In evaluating the requirements for future manned space flights, high priority is placed on a machine that will allow an astronaut to move freely in space. Such a machine is the Astronaut Maneuvering Unit, here being flight tested by Alan Bean.
Now he's going to fly around those ring lockers.
Maneuvering unit is quite reliable, quite easy to fly. As you know, I believe this is me flying it here, and then Jack flew it some, and we wanted to ask Owen to fly it since he had gone through none of the training, and he got in there and flew it just as well as either of us with the minimum of training, and it's just the on-the-job training up there. It kind of gave you a feeling that this sort of a maneuvering unit could be built where pre-flight training would be minimized, and yet you could still do the job you wanted to do outside.
A foot-controlled maneuvering unit was later tested, but in its present configuration, it got rather low marks in performance.
Free maneuver.
The future design that will shuttle astronauts between spacecraft or from spacecraft to satellite will likely be similar to the hand-operated model. In web building, Arabella was getting a handle on zero-G.
Spider appeared to adapt relatively well to zero-G. As I recall, the first day or two, she was a little reluctant to do much of anything, but she then started spinning small webs in the corners, and then attached a larger size web, similar to one that she's accustomed to spinning on the ground, to those smaller webs which were attached to the corners. And so she was able to improvise quite readily in the weightlessness of space.
The adult minnows, meanwhile, were still confused about which way was up or down. But strangely enough, their children, recently hatched aboard Skylab, came into the world without ever having to adapt to zero-G.
Okay, this is the DDR. We finished doing step 3. We're going to go back and do steps 1, 2, and then 1 again.
Will body motions of crewmen affect attitude and control of a space vehicle? This question was put to the test in a series of crew vehicle disturbance runs.
Okay, they just jumped off the wall, and you could see the excursion rather clearly on the ATM monitor. It was probably an arc minute or so. They're jumping back, and you can see the excursion up and down on the monitor quite clearly.
A force measuring system, which senses loads applied to the workshop, is matched with concurrent control system data to find the answers. The tests will clear up many uncertainties about crew motion effects and will influence the design of spacecraft of tomorrow.
Okay, now let me reach over here. I'll make it parallel to this panel with a little bump on it.
The subject of attitude and control became a more immediate concern during the second scheduled EVA. Skylab's rate gyro system, which instructs the computer as to the amount of attitude drift, had a faulty gyro package. Jack Lausma would install a new one.
Okay, Bruce, I'm down here looking at WCIU with all these connectors, and I just got the victim loose. I can't have a few minutes, the good Lord willing, and the creek don't rise, we're going to have this hooked up.
The package was installed and placed online. Within minutes, the results were in.
And for the CDR and telemetry, the six-pack is looking good. The gyros are matching each other. Good news, and now I'm going to power up the CMG again.
The EVA lasted 4.5 hours. All tasks were successfully performed. Early next day, the crew set a record for the longest manned spaceflight. They had already traveled 11.5 million miles. What's more, productivity was at an all-time high. They were now running well ahead of schedule and even requesting jobs to increase the daily workload. One such task was the behavior of bubbles in 0G.
And we will try to cause some perturbations to it again. Now you see the oscillations are much less damped, and it exhibits almost all of the pre-modes of oscillation that you would expect for more or less a ball of liquid like that. We will set up those oscillations again by just blowing an air jet on the bubble. Okay, there, it's freely floating.
There were also demonstrations of angular momentum, magnetic effects, a Wilberforce pendulum. There was even an attempt to find out about the aerodynamics of a paper airplane without gravity.
Another set of experiments that we have on Skylab is to explore the industrial uses of space. Here before you have an electron beam welding gun. Now it doesn't look like a welding gun that we have on Earth, but it's operated by high intensity or high energy beam of electrons, which will strike metallic material in this chamber, which can be evacuated, and it's capable of melting the metal and welding two pieces together. Additionally, with this chamber and the electron beam gun, we can produce perfect spheres or ball bearings. So grow crystals in here. As you know, perhaps much of metallurgy and crystal growth and the formation of metals is very dependent upon gravity. We believe that we can grow perfect crystals and perfect metal without the presence of gravity, and we're examining that particular phenomenon here in Skylab.
While most of the time was devoted to experimentation, a part of the astronauts' day was spent on the more mundane aspects of living. There were meals to prepare, cleaning, taking out the garbage, equipment repairs, personal hygiene, and always the exercise. Although a few hours away from the routine was rare, it usually found expression in the novelty of 0G. By mid-September, it became apparent that the rescue mission would not be flown. Analysis had shown that command module alternate control modes were more than adequate for deorbit, and the condition had remained stable. In addition, contingency plans were defined for the defective quad thrusters in the unlikely event they would be required. It looked like a nominal mission all the way. Skylab cameras, meanwhile, maintained a steady flow of pictorial data, such as Earth's horizon airglow. These photos will tell scientists about the behavior of ozone and its importance to the thermal balance of the atmosphere. For the science of meteorology, strong weather systems were closely documented, as were these very striking wind convection patterns. Volcanoes? They were photographed around the world to perhaps form a basis for predicting volcanic activity. The Alps, the Straits of Magellan, Italy, Gibraltar, Washington, Baltimore, the Grand Canyon, Cape Cod, the drought area of Africa. From handheld and Earth resources cameras, our planet was photographically documented as never before.
Just today, we completed our last pass, as a matter of fact, and there are going to be literally thousands and thousands of films which will be developed and used to evaluate these techniques for the study of our crops, for the study of water resources, mineral deposits, and that sort of thing. So in the area of Earth resources, I think we do have fairly immediate benefits for all of our country and other countries as well.
Okay, Skylab, and we've just went around the mocha here, and you guys are go for undocking.
September 25th, Mission Day 60. And for this mission, time had about expired.
Skylab, Houston, AOS to Norman, 7 minutes.
We undocked on time. We're moving away. We indicated about 0.3 of a foot per second separation velocity. We're getting ready to run the RCS check.
Very good, Al, and we'll be watching.
Seems like we're leaving home, Bob.
Recovery would be off Southern California by the USS New Orleans.
Skylab, the bird looks super to us. Your go for deorbit and entry.
Good news. We're ready to go ourselves. We'll see you on the ground, I guess. Is this our last comp?
After 2 months and some 24 million miles, the scientific journey had ended. They were home, back in Earth's gravitational fold.
Subjective feeling, I think, was one where your legs feel strong enough, and it doesn't feel like it's too heavy to move your body around. But I think your lateral balance is sort of funny. We didn't seem to have much problem with wanting to pitch forward or backwards. It was mostly the sideways correction.
It would take a couple of days for the crew to regain their steadiness, a normal part of the readaptive process. Many hours of medical tests would follow in which all data would be within normal limits. Long-term medical effects would take several weeks to analyze. But for now, they felt well. Their spirits were high, and they looked forward to home and family.
I didn't know we had so many friends. I'm glad to see you all here today.
Reunion took place at Houston's Ellington Air Force Base amid welcome home ceremonies. Just as they will for many months to come, the crew attempted to share some of their experiences. Experiences out of which a store of knowledge was gleaned that will shed new light on our troubled planet. And experiences that have served as a proving ground for the next Skylab mission and for our future course in space.
Man is in space right now. He's in space to stay. He will always be in space in the future. So the business we're in at the moment right now is trying to develop the abilities to carry out these explorations and advancements that are sure to come. It may not be 5 years from now, or 10, or 15, but if we could all return to the Earth 1,000 years from now, we'd find that there are many people here, but there are people that have gone from this Earth to the other planets of the solar system, and perhaps even the other stars. We've embarked upon a most fantastic journey, and it will never end.